Hey there, today we'll be doing this question that appeared in Biweekly Leetcode Contest 95 6288. Find consecutive integers from a data stream, and the given question statement is for a stream of integers, implement a data structure that checks if the last k integers passed in the stream are equal to value, and we need to implement the data stream class. So the data stream constructor says that we'll be giving a value and an integer k. Initialize the object with an empty integer stream and two integers value and k, and boolean consec int num says that we need to add it to the stream, and we need to return true if the last k integers are equal to the value, otherwise false, and if there are less than k integers we return a false. So let's understand this with an example right here. So they have given this data stream. So at first we are going to initialize our value with 4. This is our value, and the given k to us is 3. So what do we have here? We have value and k. Now we'll be given consecutive values. So at first we receive 4, which is not equals to our which is equals to 4, but our number of values which are there in the stream is less than k, so we return a false. That is here. Again we have a value similar to 4, but we have less number of value than k, so we return again a false. Now we add on 4 and we see the number of values in our stream is greater than or equals to k. Yes, it is exactly equals to k, so we can return a true right here. Now we get a 3 here. Now we see the last k consecutive k numbers are not matching, so we'll return a false. Now for this question you must be thinking, why not just take an array or vector array, whatever, okay, and we just simply push on to every last, and we just match the last k, like the last 3 at every instance. But this will actually TLE, because the number of calls that will be made to consec function will be 10 to the power 5. So if at every given instance, let's just say your k's value is 10 to the power 5, you will be doing k 10 to the power 5 number of iterations at every instance. And if the number of calls is 10 to the power 5, it will be a quadratic solution, which will not obviously help. So what we can do is, so there can be obviously many ways to do this question. I implemented it using a DQ. And what does a DQ says? A WNDQ says that we can insert or delete at both the ends. Fine. So we'll be using a DQ. Now let's understand how do we do this using DQ. So at first we are given the values, that is here, that is 4 and 3, right? Value is 4 and k is 3. So from DQ, what are we going to do? Let's see. At first we insert 4, which is fine. If and if only the value is equals to our nums that is given to us. That means whenever this consec function is called, you'll be provided a number, which is this one right here. And if it is equals to our value which we need to add, then only we are going to push it into our DQ. Fine. After we have pushed it, what are we going to do? We are just going to see that is our DQ size greater than or equals to k. If it is not, just return a false. So it is not greater than or equals to k, so we return a false. At the next instance, we see that is my value equals to my num. Yes, it is indeed, so we insert it. Perfectly fine. Again we do the similar operation, and we see that yes, we have actually gotten three values which are similar to our value, and it is greater than or equals to k. That is also being satisfied, so we return a true. Now at the next step, when we get, let's just say 3 right here, which is given right here, we see that okay, in our DQ we have now 4 values, but there is a problem. While we are inserting it into our DQ, that is here, we'll be checking, is this given value equals to the value that I need in my consecutive values? It is obviously not equal, right? So what are we going to do? We are just simply going to say I will empty my DQ. That is, I'll erase whatever things are there from my DQ. And how is that going to help us? Let's understand this better. So let's just say we had something like this, and we are getting this 3 at the next instance, right? This is 3. Now when you are getting this 3, let's just understand this properly and everything will be clear to you. Okay, so whenever you are getting a 3, I'm saying that we remove everything from the queue, dq, that is present there. And how is that going to help us? See, so we obviously need the last k, right? Since this is the most frequent element that was inserted into our dq, that means this is our inserted value. Now are we going to take these three as our consecutive elements, or these three? Obviously this one, right? We are going to take this one because in the question they have mentioned that we need to return the last k integers from the point we have inserted a new element. Fine, so they have already said it, we need to take all the last k and not the previous last k or the second previous last k, something like that. Fine, so we are only concerned about the last k. Fine, and not the second last k or something like that. So that is why even if we remove everything, whenever we are encountering a value which is not equals to my nums, or my nums is not equals to value, and we just empty our dq, then also we'll be able to actually maintain it into our answer. Now coming on to the code part, this will be a clearer one, but I'll be going through the code as well as the example once more so that it is clear to you. Now let's just take a random input statement right here: 443 44 and something like this. Okay, and the number of values that we want, let's just say, is equals to k is equals to 3 and the value is equals to 4. That is what we were wanting right now. Fine, so let's understand this code walkthrough and you'll be able to understand the whole implementation part clearly. So at first, what are we doing? We are saying that if our dq is empty, let's just create a dq here. We have said that if our dq is empty, what are we going to do? We are just going to push it into our front of the queue. So we have pushed it perfectly fine, and we are only pushing it if the given nums is equals to my value. So 4 is equals to 4, so that is why we have pushed it inside, right? Otherwise we won't be pushing it. Now next again we see that okay, it is again equal, so we have pushed it perfectly fine. Now when we are coming on, we see that okay, my queue is not empty, so I enter into this else condition, and then I see if my q dot size is less than k. Now if my q dot size is less than k, what am I doing? I'm saying that is this 3 equals to 4? It is not equals to 4. So what did we say? That whenever we are finding that our value is not equals to nums, then we are deleting everything from the queue. We're deleting everything from the queue. So this is the part where we deleted everything from the queue. And at any given instance, whenever we are deleting, if the value that we find is not equals to my value, then I'll not be inserting it also. So fine, so now my queue is totally empty. Now we move on to the next part, which comes on to 4. So at 4 we see our queue is empty and it is also equals to our value, so we insert 4. Now again we find 4. Fine, so right now our queue is not empty, so we go into this else condition. After that we see that okay, my queue dot size is less than k, right? It is less than k, and I see that our nums is equals to val, indeed 4 is equals to 4. So that is why we push it again, and this will continue till this. And whenever we are filling it up till k number of times, we are just simply going to check that okay, if my q dot size is greater than or equals to k and my q dot front is equals to value, will be returning true. So these two conditions means that it will be giving you true. And for the next instance, when we again find, when we are done with this, we again find 5, and what will it do? It will just say, instead of inserting this 5, what will I do? I'll just remove everything from my queue. Now if you even have a slightest doubt on why are we removing everything from the queue, so see, I'll just remove this part right here. just to clear this slightest doubt, even if you have it, and if it is clear, well and good. But if you even have a slightest doubt, just look into this and you'll be good to go for this one. So let's just say we have some other values after 5 which will be coming onto our DQ, right? Now, as I said, we are only concerned about the last key elements, right? We are only concerned about last key elements. Let's just say we had 5, and instead of deleting it, what we are saying, I will insert it. Now, the last 3, after inserting 5 will be this, and it will never form a what do we say, consecutive key elements which are similar. It will never form. Let's just say again we get 4 and 4. Let's just say for now we get a 4 and 4, right? Now will it form something similar to it? Obviously not. Why? See, even if you take this, it will never be true. Even if you take this, it will never be true, right? Because till key elements we are bound to get no elements as true, because this 5 is interrupting in between. So that is why even if you delete everything from the queue, even if you delete everything from the queue, what are we going to have? What are we going to have? We are going to have nothing in our queue. So as I said, when we had something like this, instead of inserting 5, what are we doing? We are deleting. And at the next instance, what were we getting? We were getting 2 4s. So this holds true for every value. Okay, so this is the whole intuition behind this code. That is, every time you get a value which is not equals to the num, you just remove everything from the queue. Just remove, and whenever you are getting equivalent numbers, what are we doing? We are just adding them into our queue, right? So this is the whole point behind this, and the code will be in the description as well. And if you do have any doubt still, please do ask me in the comment. I'll be replying to it, obviously. And yeah, this is it for this video. And if you want the code, it will be in the description. And if you did understand the code and the explanation, please like and subscribe. And yeah, thank you for